All right, Python students, let's get going on our next topic. Now that we're masters of inputting and outputting information from files, and now that you've kind of built out your utility classes with a little bit more functionality, we're ready to think about this idea of encrypting and decrypting data. Now, we're not going to be doing anything particularly resilient against attacks in this section. We're not going to be encrypting it with a huge, complex modern standard, but we're going to practice some of our skills by replicating a very famous type of encryption called a Caesarean cipher. Cipher is spelled like this. And a Caesarean cipher works like this. Let's say I had the text hello inside of a message and I encrypted it using a Caesarean cipher. Well, I have to think about how many values I want to shift my characters. Let's say I chose just a shift of 1. What that would mean is that each letter is going to move one space further along in the alphabet. So H would turn into an I, an E would be an F, an L would be an M, and an O would be a P. Ifm would be the 1 unit shift. Or maybe I wanted to do a 2 unit shift. This would be J, G, N, N, Q. A 2 character shift. Jugung. So that's a single shift Caesarean and a double shift Caesarean. I can also think about shifting them back. What would happen if I shifted this back by a -1? Well, it would become hello again. If I shifted this back by -1, it would become ifm. The one that's still 1 shifted over because it was a 2 in one direction, but -1 backwards. So hopefully this is enough to kind of see the pattern of how a Caesarean cipher works. And of course, we can consider applying all sorts of different values to shift it more or less for different messages. And we're going to be creating the code that's going to do this. But the first thing that we need to be thinking about is how do we actually manage to change characters in a string? I'm going to teach you. It has to do with this thing called Ascii values and some casting that we're able to do. So the first thing I want us to think about is how do we represent a character in Python? So I'm just going to go like a single letter. I'm going to assign a letter to this. And, well, what does Python interpret this as in terms of a data type? Let's print out the type of my letter and see what it says. It says a string class. So Python considers single letters as strings, which is exactly how Python should do it. In Java, there's a special type called a character, but in Python, we just manage them as strings. However, we need to be careful to only put a single character in for this type of conversion when we get there, otherwise we'll get an error. I'll show you right now. If I wanted to actually convert this letter, actually I'll show you in a sec. We'll get there soon. What is an Ascii value? Let's take a peek at this site, the Ascii table. ASCII stands for the American Standard Code for Information Interchange. And this is a system that's been developed to allow for information to be transformed into different forms for different types of purposes and transmissions. And it shows that there's a relationship between values of numbers and characters. Also, hexadecimal and other forms are available of different types of representations, but we're not going to worry about any of these intermediary or these central kind of strategies here. We're just going to worry about the decimal value and the character values and their relationship. This first column shows all sorts of kind of functional keys on a keyboard, things like the shift key and different control things and backspace and stuff like that. We don't want these to be a part of what we're doing here because they kind of just cause things to happen. They're not representing data in the way that we are hoping to. So I want us to focus on the numbers 32 to 126. We have 32 being the space character, just an empty space, and 126 being this tilde squiggly thing on the top left of your keyboard. And everything else in between are actual characters that will be printed out to the screen, nice and obviously, so that we can use it to store information. And space appears in this Ascii table to be equivalent to the number 32. Over here, we have the letter A. Apparently, this is number 65. We also have a lowercase a, which is the number 97. You'll see the full alphabet has a representation of numeric equivalents that we can see on this Ascii table. And we're going to be using these values to perform some casting and translations of information in this section. So now that I have this lowercase a, what is it that I can do to actually turn this into a number? Okay, so what we have here is the number equivalent, is going to be, and now here's something we just need to learn and apply in this section. We're going to turn it into an ordinal. ORD stands for ordinal. And then I'm going to print out this num, and we'll see what shows up on the screen here. 97 is the number that this letter was cast into. Very interesting. The number 97 on my Ascii table right here is exactly what we thought it would be, the letter A. Okay, what about the letter capital Z? Let's run this again, and it says 90. Look at that, capital Z, 90. There's something to this that's really legitimate. Well, what about going the other way around? Am I able to now take this number and assign it to a new letter? And, well, what do I do to this num? There's another casting tool you can use, CHR, where I'm going to turn a number back into a letter. And then we'll have this printed out, my new letter. Let's run this and take a look. It cast it back into Z. It started as a Z, became a number, and then I cast it back into a letter and printed it out. So this process is working just fine, casting from one data type to another. But here's where things get interesting. When I have this in numeric form, I can change it with some simple math. This num, which is a number, I can add 1 to it. And when I cast it back, it's going to be in a different form. So let me just have my, let's have my num get printed out, and then my letter. So 90 was the first character I started with, which is this Z. But then I added 1 to it and cast it back into a character, resulting in the next character in the order in the Ascii table. So I've now found a way to take a character and change it into something else in the way that we need for a Caesarean cipher using this kind of casting idea. Oops, I clicked and dragged there. So here we go. We now know how to use the Ascii table to cast values and change their identity. Let's try one more. What if I take an A, which should be number 65, right there, number 65. And if I shift it by 1, it becomes a B. What if I shift it by 10? Run my program. A K. Well, capital A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bam. Consistent. We can now shift one letter to any other letter. One quick tip I want to give you in advance, that's a problem that you're going to have to deal with in your future section, is what happens if I do a number, what about like Z, and I add 10 to it? Let's do lowercase z, because that's at the end of the Ascii table, down here. And I add 10 to it. 1, 2, 3, 4, 5, kind of goes off the page. Well, I'm going to run this and see what happens, and it becomes a broken symbol, because I don't have access to those values off the Ascii table in a meaningful way. Python probably doesn't support it here. So what we want to do is when we get past 126, rather than go to 127 and beyond, I want you to wrap back around to 32. What does 32 look like? Well, in here, it's a space. So I should see that if I leave, an empty space in here, write it out, number 32. And 10 above that should be, yeah, looks about right. The star sign, the multiplication symbol. The same thing applies if I go from 32 and I go negative. Like, what if I was to take this and do minus 10 and run this? Well, now I have this symbol that's in place of 22. This, synchronous idle symbol that isn't really being interpreted very well here. So if I go below 32, I want to wrap around and just have it pick up at 126 and continue to go down from there. So this wrapping around logic needs to be determined by you to avoid any of those issues. But you'll solve that a little bit later in your work. So the next thing we have to think about is that in our strings, we have more than one character. What happens if I try to change or do an ordinal shift into a number from something that's more than one letter? If I run this code, it's going to error. Ord expected a character, but string of length 3 found. What if I make it only 2 characters? AC, still an error. This has to only operate on single character strings, or in other words, a character. So we can't actually process a full string. For example, a word, if we took this word like we did above, hello, I'm not able to perform an ordinal on this word, or it's going to error. I'm just going to delete this up here for now to kind of keep that out of the way. But when I run this, length 5. So what am I going to do about actually managing to work with this string? Well, one thing that we can consider is a string can actually have individual sub-characters accessed. If I was to print out in my word, just like in an array, the 0th thing I see, H, is created from hello, the first character. Number 1 is E from hello. So I'm actually able to access all the entries. 0, 1, 2, 3, 4 would be the total. But if I try to access number 5, what's it going to do? Out of range, because I don't have a 6th, because remember we start counting from 0, character inside of here. So, okay, I'm able to actually access individual letters. So would that mean that I can just go like this? If I want to change that starting H to something else, can I just set it to a new character? Maybe I want to say Zello instead. Run this. Oh, string object does not support item assignment. We are actually not allowed to change string information. Strings are locked in. We can't change the individual letters later. Really troublesome. So what are we going to do about this? Well, we kind of have to use a little bit of an intermediary strategy to manage this. Let me show you how. I can create some, I'll call it word data here for now. And what I'm going to do is I'm going to take my word and I'm going to convert it into a list. And I'm going to see this printed out so we can see what this looks like. So I'm going to convert my word into a list form. And now we have hello. Each character is a different entry in the list. And lists are what we call mutable. Strings are immutable, not changeable. But lists are very mutable and changeable. So now, with this list of the word generated, I can go, my word data, its first entry can now equal Z. All right? And so now what happens if I print out my word data? I will see that it's Zello. I've changed this first character effectively now. And now I can just convert it back into a string. How do I do so? Well, I can have I'll just assign it to word again, and I'm going to go, I'm going to make a string, and I'm going to join it with this word data that I've generated. And then we'll print out the word. Now when I print it out, I have a string that's Zello. But I had a few steps here. First, I defined the string. Then I converted it to a list. Then I accessed the slots in the list I want to change. And then I created a new string that joined to its empty contents, the contents of my word data, which basically turns it into a string again. And now I have the changed string. So a bit of a roundabout process, but if you were clever, you could create an entire method that does this all for us. And I'm going to show you something shortly where I kind of solve some of these problems for you, kind of get you started on some encryption stuff. In fact, I think maybe it's time for us to look at it in this basic encryption section. Let's head over to the file encryptor file that I provided you. And you should actually see that I've included a bit more code for you here. A few helper methods in this utility file for encrypting that I provided for you. The first utility takes in a character and returns the integer version of it. It does the casting. Sorry, I got something in my throat. One sec. Excuse me for that. And another helper method that converts a number back into a character. So I've created a couple helper methods that help manage this casting to and from, but this is the really helpful one. Encrypt String. I send it a string message, and then I hold a temporary string that's going to be the holder for it, and I convert this message into a list. I called it message list. Then I loop through all of the entries in that list. I should probably put some comments here. I might do that. You might see that on your screen after I do it here. But for each character in the message list, I'm going to do the conversion. I could have used my helper methods here, but I'm going to cast it directly into an int, and then I'm going to shift its value by 1, and this new character, I'm going to concatenate it to my string. So doing a slightly different strategy than I did over here, where I joined the whole thing, because I converted them just a single entry. Because I'm doing them kind of one at a time in this strategy here, where I'm taking out the character and just kind of converting it, then I'm able to just concatenate it to another string. I could create a separate one that does that whole actually change the list contents and prints it out if I wanted to, but I decided to go with the strategy in this context, and you can kind of fix and change things as you see fit to make it work in the way that you'd like. Once this new encrypted string has been built, I'm going to print out encrypted message plus the encrypted string that I've now created using this functionality. Let's take a look at it. So I've already instantiated an encrypt function. I'm just going to erase this stuff up here for now. So I'm going to go, hey, encrypt. I want you to encrypt the string. And let's do our hello string and see what is printed out from that. Ifmp. That looks familiar. It's when we actually adjust a string, the strings hello, we did this above here, by a single value. Look at that. Now we have an automated way of doing this rather than doing it in our head. However, let's update this one more time to make it a little bit smarter, because what I want to have my encrypt string be able to do is not just update it always by 1, but I want it to do it by some kind of key. How much do I want to shift it by? So instead of always shifting it by 1, I want to shift it by the key value so that I have some customization in this. So now if I go hello 1, I'll see it prints the ifmp, but if I put in hello 2, it's going to go to the jugunk. And if I go hello 10, it's going to go ravi. Now, if I put in like 50, I'm going to have some problems because I've gone out of bounds now. So what you will need to do, this is one of your tasks, is to figure out how to add some conditions into here so that if I'm trying to shift a character by too much, it ends up wrapping back around so that if it goes past 126, it ends up going back to 32 and continuing down this way. Or if I go a negative value, which I can totally do, let's take a look at my runner. If I go -1, everything is shifted back by a character. I can wrap from 32 back over to 126 so that we stay in the range that gives us meaningful outputs of information. So there we go. We've now been able to set up our first example of creating a Caesarean encryption, and your main task is going to be to solve bigger and better problems encrypting and decrypting data as you build towards having an automated system of doing it for you in different ways. I think I'll release one more video after this with a few more tips for the project, but that's going to be all for this set of strategies.